Hello. uh, One of student he asked a question, and the question is about I think it's a third or fourth year math in economics class, and they asked the question, and the question reads as to consider the production function of y again, sorry for a few seconds of a delay. I had a problem with getting my pen to work. So again, a student is asking a question, and it's about following production function where y is equal to f capital on labor, and that is equal to t k alpha and also L to the power of beta, where K and L all represents capital and labor inputs respectively. T captures technological progress, and it assumes that it's constant. Alpha and beta, the two parameters or two positive parameters, means that alpha is greater than 0 and beta is greater than 0. So these are by positive parameters. This is what we mean. So the question is for A is asking, study the homogeneity of the production function and how would this output change if the firm doubles its input, if changes in output. So as I said, that this is a Cobb-Douglas production function, which is based on the empirical study of the American manufacturing industry made by Paul H.D. Douglas and C.W. Cobb. It is a linear homogeneous production function of a degree 1, which takes into account two inputs, which is capital and labor, for the entire output of the manufacturing industries. So this function could be written as Q is equal to A, or here is it T. Can write K to the power of alpha and L to the power of beta, where Q is the output and NLK, K and L are labor and capital respectively. Alpha and beta are positive parameters, as again I said, they're both greater than 0. So the equation tells that the output depends directly on capital and labor, and that part of output which cannot be explained by labor and capital is explained by this T, which is a residual, often called technology changes or technological changes. So the question is asking to see if how would the output changes if the firm doubles its input. So in order to do that, we need to do the following steps to solve this equation. So we have y is equal F times KL, that's the two inputs, and that is equal to the T, K to the alpha, L to the beta. So we can increase the F factors, W times K and W times L, and that is equal to T times WK, increasing the factors by W, and also LW, L to the beta. So just doing a little bit of math, we can solve this as T, W to the power of alpha, K to the power of alpha, and so is W to the power of beta, and L to the power of beta. And that will be equal to T. We can write W, it's alpha plus beta, because they're both the same, A plus B, and we can write as K and L. This is alpha and this is beta. And therefore, we can write this as W alpha plus beta times, this is our function, which is giving that's F K of L. Now, Let's go to the next page. So the question is it homogeneous? Yes, it is homogeneous. How do we know it's homogeneous, of what degree and what scale? So if alpha plus beta is equal to 1, then that's constant return to scale. If alpha plus beta is less than 1, then it's decreasing return to scale. And last, alpha plus beta is greater than 1, then it's increasing return to scale. So these are the definitions. Now, the question asks, what if we double the inputs? What happened? So if W is equal to, means we double inputs, then obviously the output will increase by, since we have W is equal to 2 to the power of alpha plus beta. So that's your answers for part A. For part B, it's asking find the marginal product of capital. So for part B, it's asking to find marginal product of capital and marginal product of labor. Now, so just one thing for part A to continue, it says the homogeneous production function. By definition, a linear homogeneous production function implies that with the proportionate change in all the factors of production, the output also increases in the same proportion, such as if the input factors are double, the output also get double. This is also known as a constant return to scale. So in economics, factor of production, as the name signifies, are the inputs of, say, resources acquired by the firms to use them in the production of goods or services so as to earn a profit. The word production refers to a systematic process of converting the inputs into finished product, which can be goods or services. But for this purpose, the product has to pass through different processes, stages, and hands to reach the final consumer in its consumable forms. So the production level is based on the quantity of inputs and production capacity of the firm. And we all know that the factors of production, basically there are 4 factors of production, and on which the entire process depends. And that 4 production factors are land, labor, capital, and entrepreneur. Now, this was part of question part A, which I forgot to mention just as an explanation. Now we're going for part 2. It's asking for the marginal product of capital and labor. So marginal product of capital and marginal product of labor is an economic terms that describes the incremental changes in a production when there is an increase in a capacity or increase in capital by 1 unit or in labor. If this statement doesn't automatically make sense to you, then probably it's going to take you a while to think like an economist. But anyways, don't be deterred. You will get there, and I'm sure that you will understand. So marginal product of capital as well as marginal product of labor is the marginal product of labor can be valuable for any small businesses looking into increased production. Why? because it shows whether or not the extra investment will return enough to cover the increased cost. We can give an example. To understand the marginal product of capital, it helps to see a company as a system. For example, like a machine. If you feed time and money into the company, and then the company produces good, so you have a money and a time, and then you spend it into the firm. So I was saying, if you feed time and money into a company, then the company produces goods or services. The firm produces goods and services. And the more time and money you put in, the more goods or services the company should produce. However, the time you invest in a company isn't always your own. So it is best to refer to it as labor. And similarly, the money you put into a company isn't always your own money, because you may borrow that money, and it's best to refer to money as capital. So instead of saying that you put time and money into a company to produce goods and services, you can now say that you input capital and labor to get an output of goods or services. Now you're talking more like an economist. So now the question is how to calculate the marginal product of capital and marginal capital of labor. Marginal capital, product of capital, can be calculated very easily if you know what the changes in output will be based on your increase in expenditure. So in order for this formula to work, there should not be any other changes to production except capital. So marginal product of capital is equal to change in total output divided by change in capital, which is marginal product of capital is equal change, or change in PU, a change in K, and marginal P of K of L is change in P with change in L. We can write this notation in a very simple way. So in order to calculate, to answer the question, so marginal product of capital is change in F, K of L, which changes in K. So with respect to K, you take the derivative of the function. So we're taking the derivative function, the derivative, because our function was T, K, alpha, L to the Bravo. So therefore, by taking the derivative of this with respect to K, so we have alpha come down, T, K, taking the derivative, it's alpha minus 1, and L to the B. So marginal product of capital is equal alpha T K alpha minus 1 alpha minus B. So that's your answer for marginal product of capital. For marginal product of labor, same thing. We have a changes in F, K, and L respect to changes in L. Again, taking a derivative of this now with respect to L. Then we have a B, beta, T, k to the alpha L, since we're taking the derivative with respect to beta, then that becomes beta minus 1. So the marginal product of labor is equal to beta T k to the alpha L to the B minus 1. That is your answer for part B of the question. So that is that marginal product of capital is equal to this, and marginal product of labor is equal to beta T k to the alpha and L to the beta. Now for part C, I think there's a part C in that question he's asking. Assume that beta for part C. So assume that beta is equal to 1 minus alpha. And it's asking show that Euler's theorem holds for the production function. Okay. So we know from the Euler's theorem that K times marginal product of capital plus labor times the marginal product of labor, and that is equal to our production function, which is K times L. All we have to do is just do some arrangement, and it's K times M PK plus L times MPL, and that is equal to K times alpha T k to the alpha minus 1 and L to 1 minus alpha. Okay, that's this, and this is this. Let's make it a bracket. And plus L to 1 minus alpha T k to the alpha L to minus alpha. If we rearrange this one, then that would be L times T, that would be K to alpha, and we have L to 1 minus alpha, and that is plus 1 minus alpha times Tk to the alpha and L to 1 minus alpha. Further simplifying this, you can put T k to the alpha L to 1 minus alpha, and then we have alpha plus 1 minus alpha. So this will cancel, that will be 1. So we have f of k of L times 1, because we have 1, and that is equal to f k of L. So therefore, the Euler's theorem holds. So that was answers to the question. I hope you enjoyed it, and please don't forget to subscribe to the channel and press the bell icon so you can see these upcoming videos. Thank you. Take care.